Hello everyone. Today this video will be about the 5th FRQ of the 2014 AP Calculus AB test. Here's what the FRQ looks like. Part A of the FRQ asks us to find the x-coordinate of each relative minimum of f in the interval -2 to 3. Now, we know that for any minimum to exist, f prime of x at that point must equal to 0. And also, for it to be a minimum, f prime of x in the interval before this x value must be negative, and after that value must be positive, so that it forms a minimum. Now with this information, we can go into the chart and look. This is f prime of x. Between the values -1, f prime of x goes from negative to negative. This is not a minimum, so we keep looking. At x equals 1, f prime of x goes from negative to positive. That's great, so it must be a minimum, right? Well, we need to make sure if the derivative at that point is 0, otherwise it still wouldn't be a minimum. But here, we can make sure it is a minimum because f prime of x at x equals 1 is 0. So for A, our x-coordinate is equal to 1. As a justification, we can say that since we know x equals 1 is a critical number, since this is a 0, then we can say that x is equal to 1 is the only critical number of f of x that where its derivative changes sign at x equals 1 from negative to positive. There's the justification. I also purposely made a mistake in this justification so that you guys would realize that it is not a very good word to use. Instead, you should say x equals 1 is the only critical number of f of x where f of x's derivative changes sign from negative to positive. Or you can simply say where f prime of x changes sign from negative to positive. This makes it much better and less vague to the AP readers. Now, on to B. It's asking, explain why there must be a value c for c inside the interval -1 to 1, such as f double prime of c is equal to 0. Now, asking for a value c in a certain interval, such as f double prime of that c will have a certain slope, reminds us that we have to use the mean value theorem, or the MVT. The MVT basically says that inside a closed interval a and b, in this case a is -1 and b is 1, that is continuous and differentiable. It's guaranteed right here. The differentiable functions are defined, which makes it continuous. If it's continuous and differentiable in this interval, then the slope of the secant line between the endpoints of this interval will have the same slope as the tangent line at some c on the function itself. Which is why, to explain this, we will need to find the slope of the secant line, which we would find it by using the slope formula, which is f, in this case, f of b minus f of a over b minus a. Now this we've seen a lot of times. It is the slope formula, and it is part of the mean value theorem. And by plugging in the values we need, since this is f double prime of c, we will have to use f prime of c, and the value of b and a, where it's b being 1 and a being -1, we have 0 and 0, so we end up having 0 minus 0 over b minus a, where b is 1 minus -1, which is a, where we get 0 over 2, which ultimately equals to 0. Now, this we have is the slope of the secant line between x is equal to -1 and x equals to 1 of f prime of x. And this f double prime of c equals 0 is the slope of the tangent line of some point c that's guaranteed to us by the MVT. So by this, since the secant line slope is 0 and the value c, the slope at that point is also 0, then the MVT proves there's a value c in this interval such that f prime prime of c is equal to 0. So our explanation here would look something like this. This explanation was taken from parts of the question itself, and it reads, by the mean value theorem, there's one value c in the interval -1 to 1 such that f prime prime of c is equal to 0. Computations. So to find h prime of 3, we would take the derivative of both sides, so that then we can plug in the number 3 to the derivative we get. So part C, we have taking the derivative of both sides, we get h prime of x is equal to, this is the chain rule, and the derivative of ln of x was 1 over x, and in this case x is equal to f of x, so you get 1 over f of x times the inside, the derivative of the inside, which is f prime of x. And to solve for h prime of 3, we plug in 3 to x, and we get h prime of 3 is equal to 1 over f of 3, which is 7, times f of x, or in this case f prime of 3, which is equal to 1/2. And by this we get h prime of 3 is equal to 1/14. Okay, so part D asks us to evaluate the definite integral from -2 to 3 of f prime of g of x times g prime of x dx. And in order to evaluate this integral, we would need to use the fundamental theorem of calculus, which asks us to find the antiderivative. Now, you should be able to recognize that this is a chain rule, and the antiderivative of that would be f of g of x. Now, using the fundamental theorem of calculus, we evaluate this antiderivative from -2 to 3, getting f of g of 3 minus f of g of -2. And from the chart, we can see that g of 3 is equal to 1, so this equals to f of 1 minus f of g of -2 is equal to -1. So, and by evaluating this, f of 1 is equal to 2 minus f of -1, which is equal to 8. We get this is equal to -6. So, after solving the FRQ, last but not least, we have some references. Over here on the left side, we have Khan Academy videos, very helpful. Here's the part A, B, C, D of the FRQ, and which parts relate to them. And the book means the book we use in class, Calculus Early Transcendentals by James Stewart. So for part A, it has to do with relative minimums. Section 4.1 tells you what a relative minimum is. Section 4.3 tells you the relationships between minimums and derivatives, and along with the first derivative test, which has to do with the derivatives. And here are some practice problems on finding minimums and maxes. Part B involves the mean value theorem. 4.2 is the reading is all about the mean value theorem, and 4.2 here are some problems involving the mean value theorem. Part C has to do with understanding the chain rule very well so that you can spot it, and section 3.4 is all about the chain rule. 3.4 of these problems are about evaluating the chain rule, and 3.6 is about logarithm, in which in part C there was the ln of f of x. So you would need to know the derivative of ln of x, which is in 3.6. And part D, there's the chain rule and the fundamental theorem of calculus. Section 3.4 again talks about chain rule. 5.3 talks about the fundamental theorem of calculus. And 5.3 problems 19 to 40 are all about using the fundamental theorem of calculus to solve equations. And 34 is about a hyperbolic function, which we in class have not learned. Thank you so much for watching this video.